No. All right, we are now live. We have to make sure people can hear us because we're going to be kind of far away. All right, hey everybody. We are in my backyard today, actually, because we found it easier to have both people in the screen, and we honestly have a huge buffet of food here that you can't see. So I would appreciate it if you could say whether you can hear me or not. Yeah. Hi, everybody.
I can't read that. Can you read that?
I can read it, and I can also move a little bit closer. So if you can hear me, can you like give a thumbs up emoji or something? Because I am a little far away. But until you say something, I'm just going to assume that you can hear me rambling in my backyard. We can hear you. Awesome. Thank you. All right. So my name is Caileen Brison. You have seen me before. I am awesome. Thank you, guys. I am SciCommunity's token enologist, which means I am a wine chemist, but we've never actually sat down and talked about what that means yet. And so today we are going to actually sit down and talk about what we do on a day-to-day basis. I actually just left my enology position like an hour ago, so we are in very like real work mode. This is my friend Abby. So Abby is one of the people that got me into enology. So if you remember from episode episode 3, we had Ken Sweggles on of Rises Viticulture. Abby is Ken's wife, and they are like super awesome wine power duo in the Santa Cruz Mountains. And when I was starting to think about enology as a possibility, I approached Abby, and she was like, kind of tried to get me in at a couple places, was incredibly helpful in that process. And so today we're going to sit down and talk about the shit that we do on a day-to-day basis, basically. So before we get started with that, though, Abby, can you talk a little bit about who you are and then how you got into wine?
Sure.
While I drink wine.
I'm Abbey Chrystal. I actually grew up in Columbus, Ohio, or Worthington, Ohio, just north of Columbus. And how did I get into wine?
Want some salad making?
I did a lot of working in restaurants, kind of getting through school, and got a lot of great wine education there. So it started my passion for wine at that point. But I actually took a decade-long trajectory in a different way in academia, working in. Got distracted again by the wine industry and ended up transitioning back into wine world. And by that time, I had gained a skill set in applied chemistry, and so that was really useful in the wine world. Your
background is in the hard science, environmental sciences, right?
Environmental science, earth science, I think would be a good way to encompass it. I was like doing ocean chemistry research.
Yeah. And do you mind saying what track you were down for a while?
Sure. I was looking at biogeochemistry, so looking at small organisms that build a calcium carbonate shell around themselves in the ocean, plankton organisms, and when they die, they settle out and into the ocean sediments, and you can actually look at those layers and look at the chemistry of their shells to reconstruct what the environment was like at the time that they were living. So I was looking at glacial cycles. People looked millions of years in the past doing that too. So all kinds of things you can do.
Yeah, really cool stuff. And that's also kind of a nod as well to say that, I'm shedding, that's a nod as well to say that oftentimes enologists have a pretty diverse background of skill sets, because the fundamental thing that unifies all of us, I think, is that we do think like a scientist. We were actually talking about that today at work, because I had a day at work, suffice it to say, and it came down to just how people's brains think differently. And as scientists, I think that we think fundamentally differently. So if you're sitting and watching and thinking to yourself, like, do I have what it takes to be an enologist? Ask yourself, do you think like a scientist, and do you consider yourself a scientist? And if those two questions have the answer of yes, you're probably good to go. So Abby, can you define for us what an enologist is?
Sure. I guess an enologist would be an expert in the science of wine, and there's definitely some overlap between being a winemaker and being an enologist, but you can be a winemaker without being an enologist, and you can be an enologist without being a winemaker.
Correct.
But a lot of people are both.
Yes.
And, if you go to Davis or one of these other winemaking and enology programs, you're going to end up with a degree in winemaking and enology, and so you'll get that time spent digging into the actual chemistry of wine.
And we'll talk a little bit about like the Venn diagram of overlapping winemakers to enologists, because there is a lot of overlap in the middle, but there's also some pretty distinct roles on the outside. So, Abby, you are an enologist, and you are coming into work. What is the first thing you do at work?
Well, it depends on the time of year.
Yeah. Do you want to talk about the life cycle of an enologist?
Sure.
As far as like a year in enologist.
Sure. So this time of year is a great place to start, kind of the start of the life cycle of a wine. It's harvest. So what we're doing now is looking at the grapes as they ripen. We're looking at the sugars, the acidity of the grapes as they ripen, and deciding when to pick them. And then as you bring the grapes into the winery, you're looking at things like, of course, that starting sugar level and thinking how that's going to translate into alcohol. You're looking at the amount of nutrients, basically the nitrogen that's available in the grapes, and how that'll affect the yeast as they go through fermentation. Looking at the acidity, the pH, and the titratable acidity. We'll define some of these in a little bit.
Harvest is arguably a pretty busy time for everybody.
It's hectic.
Yeah.
So we're monitoring the ferments as they go through. You're checking the bricks, the sugar content, watching that decay away as the yeast ferment, and checking the temperature. The temperature is important depending on the style of wine you're making, you want it to keep the temperature in a certain range to keep the yeast happy.
Correct.
So harvest time itself is really a lot of just messing around with ferments and simple analyses every day, but a lot of them.
A lot of analyses.
Yeah. And then as you get to the end of the ferment, you are doing things like switching over from measuring bricks, which is sort of a larger scale sugar analysis, so weight percent measurement, and now we want to be sure that all the sugar is gone from the ferment, so we switch to a molecular analysis of sugar. We can talk about this later too, but looking at the actual amount of glucose or fructose that's left in the wine, and maybe look at the alcohol. We will start measuring the volatile acidity, which is an indicator of getting a baseline for that for the wine for long term. That's an indicator of spoilage.
Yeah, if you remember from Megan's interview, we talked about volatile acidity a little bit. Plot twist, Megan's actually sitting right here. She just got done doing harvest, so well, not done doing harvest. She's about just over halfway through her harvest. So Megan from last week's Evenings of Enology is actually sitting here and just doing the fun part of drinking the wine and eating the food. But we talked about VA last week. So VA is volatile acidity. And we read it out as acetic acid composition. And acetic acid composition is a function of acetobacter activity, which is a type of bacteria that can be in wine and can cause spoilage, like Abby mentioned.
Okay, so that's primary fermentation. We started talking about, then you're going to be moving into, with most of your wines, again, depending on style, secondary fermentation, malolactic fermentation, which is a lot of tracking of watching that malic acid decay away. And again, you don't want there to be any left if you're trying to have a full malolactic fermentation, so that there's no chance for spoilage later, or at least minimizing chance for spoilage later. So we're looking at that in molecular terms, monitoring the volatile acidity. And then as the wines enter into that time period, the aging time period, where they're in barrels or their tank or whatever, waiting to be bottled and going through the chemical changes that kind of make them a little softer and smoother and more palatable, we're monitoring volatile acidity. We're checking the sulfur content change as well. I do a few other different. I look at like NTU at the turbidity, making as the yeast kind of die and settle out as the wine clarifies. That's an indicator of. Yeah,
we can talk about that because I don't do that at my winery. So there's a lot of things you track during harvest. So now let's think that in the life cycle of an enologist, you're done with harvest. Your wines are all dry. We hope. Let's say it's like January, February. What are you doing as general cellar maintenance now as enologist? What does that part of your year look like?
For me, it's there's still a lot of things that are going through malolactic fermentation, so it's still daily or at least weekly batches. And we use So it's collecting samples, running the assay, basically just making a little bunch of little test tubes or cuvettes of those reactions and then analyzing those.
Yep.
And then malic acid dryness, we can then begin to sulfur the wines if that's what you like.
Yeah.
If that's how you do it.
Yeah.
And we
if you,
do
if
do
you're,
a
if you're
moderate
pro
amount.
sulfur. Yeah.
Yeah. And yeah, so I mean, affectionately termed barrel monkey time, just climbing around and things and getting samples. And
yeah, barrel monkey is a great way to describe our job sometimes. Yeah, it's true. You're constantly fetching samples. And then let's say you're done with malolactic fermentation, so your secondary fermentation is done, and now it's summer, essentially. What does your summer look like as an enologist? Summer, sorry, that was really exclusive of me. Summer being, for us, May to like August.
yeah, Northern Hemisphere.
Northern Hemisphere.
Well, generally, I'm just doing what I call a monthly analysis. So I set lots of wine up so that I check in with them every month. And so every week I have a lot of wines that I'm checking in on, and I'm looking at pH and TA, volatile acidity, sulfur, the turbidity, which I mentioned, just like the clarity of the wine and how that's evolving over time. And that's it. Yeah, just basically quality assurance, keeping an eye out for any microbial issues that might be developing with the wine, tasting, smelling, just we're getting ready to bottle. We're thinking about when we're going to bottle these wines. We're trying to decide when that will be. Ideally, you like to bottle before harvest or after harvest, not during harvest. So anything you can get out of the cellar before harvest is always nice.
Exactly.
But sometimes things aren't ready, and then you just have to wait until the next winter or something.
Yep. Yeah, we were talking about, I think it was Megan and Alyssa and I were talking about practicalities sometimes of winemaking. Sometimes you'll put stuff into stainless, like white wine you'll put into stainless. It'll say stainless, 4 months. And that's probably because it was in the way before harvest. And if you put it into stainless, it'll be out of your way and it won't be in barrels anymore, and you have more room in your winery. And that stainless finish does do a nice kind of reductive thing to the wine as well. So it's a 2-for-1 deal, but there is practicality involved sometimes. So let's start breaking down what some of these assays actually are and when you might use them. Okay. And so I think the first big one, and you can differentiate between these two because there is a difference, when you would measure bricks and when you would measure what's called glue-through. And how do you measure those in a practical aspect?
Sure. So again, bricks is like weight percent sugar on a particular scale that was developed by someone in Europe that we've adopted here in the U.S. and it works. It's basically equivalent to grams per 100 milliliters of sucrose per 100 milliliters of wine, which is a unit that Caileen and I don't like, but that's okay. That's a whole another discussion.
Yeah. Whenever someone talks in bricks, I have to convert it in my head. Yeah.
But the point being that you use that when you're talking about juices and ferments, because you're talking about sugar on a macro scale at that point. And then when you're looking at a dry ferment or trying to get your ferment dry, you need to be looking, we're looking more on the order of, 2 grams per liter. I like 0.2 grams per liter for calling a wine dry. And because your density scale kind of gets all offset by the presence of alcohol, you can't actually use the density meter at that point. So you need to be looking at sugar a little more closely, and we can do that molecularly. I use an enzymatic test kit.
Same.
And we don't develop them. You just buy kits, and the chemistry generally seems to rely on a concurrent reaction that oxidizes or reduces NAD to NADH or back and forth.
Yep.
And then you look at the absorbance of that wavelength before and after the enzymatic addition, and that difference is corresponding to the concentration of the analyte of interest.
Right, because we're looking at sugars, and sugars are something that we've understood from a metabolic perspective for decades, we can very easily almost hijack that system where we say we have a purified enzyme in vitro and we know it will convert. I think the first step in the glue-free one I think is pyruvate dehydrogenase, and it eventually gets down to taking glucose down to a process that requires NAD+. And that is NAD+ is a big aromatic multi-ring compound that has a beautiful UV vis spectra. And so we can kind of rely on that as our output for a lot of assays. I don't know about what your lab looks like. I've been in your lab for like 20 minutes. But in my lab, we have a machine called a ChemWell, where you can run like 50 samples in a pretty short amount of time as long as you set them up. There's an auto sampler, so on one side you'll have all of your samples, and then you'll also have your reagents, and then there's a little auto sampler head that comes in and pulls your sample out and mixes it in this tiny little cuvette. It's like as big as half of your finger, not even like as big as like the tip of your finger, and there's 5 individual wells even within that, and then it'll run micro reactions, less than 500 microliters typically, and it'll just kind of plow through those in like a UV vis auto sampler manner. So from an enologist perspective, it's really nice because I can collect all those samples, or have somebody help me collect all those samples, set up the machine, and hit go, and it just runs all my samples for me.
Whereas I spend all day doing all of those analyses.
Oh, that sucks. Yeah,
that's okay.
That was like the first thing I did when I got hired. They were like, "We have this thing and we want it to work. Can you fix it?" And I was like, "Well, I make no guarantees, but like I'll try."
I'll try.
You know? Yeah.
Yeah. So we were just saying about the sugar analyses, just to circle back, that towards the end of fermentation, you're going to use more of the molecular analysis, and then when it's dry, then again you're knowing that you can move on through your secondary fermentation if you want, or if it's a wine that's not your style, you're not going to do malolactic fermentation, you can go ahead and add sulfur as you like.
Yeah, exactly. So kind of segueing then from what we call glue-free or bricks, which is a way to measure sugar content either on a macro level or on a more micro level. She's been mentioning this term called a secondary fermentation. The primary fermentation is the fermentation of sugars into alcohol. The secondary fermentation is the conversion of malic acid into lactic acid, I believe. That's what it gets converted into directly, right?
Yep.
Yeah. So how might you track the conversion of malic acid into lactic acid, and what does that tell a winemaker?
Well, I think there's a couple important things about that malolactic fermentation. First of all, it just changes the sensory characteristics of the wine in often in an appealing way, gives a little bit more body to wine. Malic acid is the really kind of sharp green, like apple-y acid, and lactic acid is a little softer, rounder. It actually is less acidic than malic acid.
As far as a pKa is concerned?
Yeah, you're going to have to get into the geeky part of that.
Yeah.
But it is less acidic.
Yeah.
It actually changes the amount of hydrogen ions that are available in solution, and so your pH actually does increase a little bit.
Yep.
And your titratable acidity will change as well. And those things you kind of have to take into consideration. Because this microbial stability of the wine and the effectiveness of SO2 is so dependent on the pH of the wine, you really do need to understand how that's going to change. But it's predictable. It's a predictable relationship. So
yeah, absolutely.
Your decision of when to harvest your wine and what acidity to start your fermentation at should involve thinking about the final product, depending on the amount of malic acid that you have in that wine as well.
Correct. So, I'm going a little off topic here because I'm just curious from a perspective of wanting to learn, but if you wanted to stop malolactic fermentation, could you add SO2 or filter?
Yeah.
Okay,
totally.
yeah. Because you can either inoculate or not inoculate, and if you don't inoculate, you're going to have a much slower fermentation, and there are going to be bacteria around that will inherently carry out malolactic fermentation. But it's just interesting to think about from a winemaker's perspective. If you ask your enologist, what are our malic acid levels, the number that you give them has a direct correlation on how that final wine is going to turn out, which is also why it's really important to make sure you have very good hands. So piggybacking again off of microbial activity in wines and malic acid activity in wines, can you talk about measuring SO2 and the different kinds of SO2 you can measure, or why you would even care to measure them?
Sure. Well, again, SO2 is helpful in an antimicrobial sense as well as an antioxidant sense. It helps protect wine from oxidative reactions. And it is a soluble gas, so it has an acid-based chemistry. And the active form that has the most antimicrobial properties is the actual SO2 form, which is in very low concentration in the natural pH of wine. But as you move higher, I think Megan talked about this last week, the natural pH range of wine is somewhere between around 3 to hopefully not 4, but like 3.7, 3.8 is tough. But 3.2 or 3.3 around in there is like your best area for having a wine with not too much acidity, not too sharp, and still having a pH range where you have enough active CO2 or SO2 to be an effective antimicrobial. Mm-hmm. And then let's talk about measuring it. There are limits on the total amount, so of free and total sulfur that are there. So you do need to keep track of that, and it can change throughout the life cycle of the wine. It can get munched up and sort of disappear, so you do need to add more. Free sulfur is the amount that's actually free, unbound, and floating around and able to act as an antioxidant or an antimicrobial agent in your wine. And then there's also sulfur that gets bound up by molecules in the wine, by acetaldehyde, by tannins, by organic matter, other things.
By lees even, so by like dead yeast particulates. Dead yeast particulates can also bind up SO2, and they'll be in what, and they'll be in what Abby is calling like the bound SO2 fraction.
Yeah. So you measure free sulfur, the stuff that can come out that's not easily, that's not really bound up, and then you can measure the total sulfur, which is that free part plus the stuff that was bound up. And so if you want to know just what the bound was, for some reason you can subtract those, but normally we just measure free and total.
Yep.
There's a couple different ways to measure. I use a system called Aeration Oxidation, which is a cool little distillation that happens. Basically, you acidify the wine sample under vacuum, and all the SO2 comes out because you've pushed it all over into that gas form. And then you condense that into another vial with hydrogen peroxide in it, which oxidizes that reaction, gets it back into solution, and then you titrate that. Now it's just a direct conversion of the sulfur, and then you use sodium hydroxide to titrate that and calculate that.
I think we use 3 different systems.
Yeah.
Yeah.
Because you use enzymatic.
Yeah, I use a couple different ways. So I essentially do what you're doing, but in a machine. So I don't have a distillation apparatus involved, but I do a titration. So I measure SO2 or free SO2 in 2 ways. One of them is a redox titration, where I'm just quite literally titrating in small amounts of either a low range or a high range titrant that reacts with free SO2. And it tracks so the output is in millivolts. So you watch how the millivoltage changes across this titration, and the inflection point of that millivoltage titration gives you your free SO2 in parts per million. And then another one that I use that is not as reliable but is quick because we can use it on that fancy pants machine that can put a bunch of cuvettes through it and shit. That one is a UV vis dependent reaction that requires the oxidation of SO2 to create a free radical species, and that free radical species can then react with this compound called p-rosalin, I believe, which is a really beautiful color of purple, by the way. So if you go back and look in the SciCommunity stories, you'll see like all these purple cuvettes in the background. Those are my free SO2 cuvettes. And we can get plus or minus 2 or 3 ppm with that. So if my winemaker is like, Caileen, we got to run like the whole cellar today. I need you to do 150 sulfurs. I rely on that thing because I can actually get 150 done in a day, which is insane. Like, yeah. So another thing we measure all the frickin' time is pH and TA. You want to talk about that?
Sure. pH is like measure of the hydrogen ions in the solution, basically, measure of the acidity. And then titratable acidity. sort of an approximation of the total organic acids in the wine. Not you basically titrate to a decided upon endpoint, which generally in the U.S. is 8.2, using sodium hydroxide, and then that is mainly going to be tartaric acid with wine or with grapes in general. A little bit of malic acid, a little bit of citric acid, but there are some other acids and some other molecules in wine that kind of interact with some of those hydrogen ions. So you don't actually get all of the, you can't titrate all of those protons.
Correct.
So we use titratable acidity as a sort of a benchmark to let us understand how much acidity is in a given wine, but it isn't actually the total acidity that's in that wine. It gives us a lot of information, and it's fast. You could go send it off and look under with mass spectrometry and all kinds of other stuff and get the exact total acidity, but that would be expensive, and you don't really need to.
Yeah. So one of the like pet peeves sometimes of me is when someone
Pet peeves of me.
The pet peeves of me is when someone interchangeably uses total acidity for titratable acidity, and they're not the same thing. They're really friggin' close, but they're definitely not the same thing. So we mentioned this in passing, but nitrogen levels. When might you measure nitrogen levels, and what can they tell you about a wine?
Generally, you are going to measure those sort of the beginning of a fermentation, or if you have a stuck fermentation, you might check. Certain yeasts do have a pretty particular range of nitrogen requirements, and all yeast require some amount of nitrogen to ferment. And there's often, depending on the vineyard and the actual grapes, there's often not enough nitrogen in the juice, in the must, to complete fermentation. Or even if you can complete fermentation, it might be slow, problematic, and the yeast can be stressed and produce some off compounds that are unpleasant odors. So we tend to check in the beginning and make sure that there's enough nitrogen available for the yeast, and if not, supplement. And basically the nitrogen forms that can be used, that yeast can use, are ammonia and then most, but not all, amino acids. So the analysis that I use to get a baseline number is actually requires 2 measurements on the UV-Vis spectrophotometer. So I do an enzymatic reaction to look at ammonia, and then an enzymatic reaction to look at the amino acid nitrogen.
Buddy. Sorry, just responding to people who are waving.
Mm-hmm.
Hi. And then I'm going a little not off script. I have it in my head, but my computer is actually holding up my phone right now. We can also measure, obviously, alcohol concentration. Mm-hmm. Sorry, you didn't get to drink your wine.
I've been drinking it. Sipping. Yeah. Alcohol, I mean, obviously, we want to know what the final alcohol is. It's actually required that we have that on the label. And above 14% alcohol is a different tax class than below 14%. And they're pretty strict about that. So if you're, at 13.9, you've got 13.9 on your label, but you're really 14.2, you can get in trouble. And they do sometimes check. So the most general way, the easiest way in a lab to look at alcohol is with an ebuliometer, which is
what?
Ebuliometer.
Ebuliometer?
Ebuliometer. Yeah, where you're comparing the boiling point of water and the wine, and then there's an easy little chart that you can use to read the alcohol off. But those have kind of a plus or minus maybe 0.5% error on them, and if you're doing a good job and it's a good piece of equipment. And so if you're close to that border of over or under 14%, you probably want to send it off. And actually, in fact, to get a good analysis, it takes me about an hour, and then plus the time to collect samples. So it costs like $20 to send it off. So depending on how many we have to run, it's often just 1 or 2 at a time.
Yeah.
We usually just end up sending it off, and then we have a certificate from a certified lab saying what they got. So if there's an error, it's it's not on me.
Yeah, yeah.
I didn't do it.
Seriously, yeah, because that would be a lot of
it could be a lot of
on
money.
your shoulders.
Yeah. That's one of the things that can really cost a lot of money.
So someone who just joined with their glass of wine, thank you, asked if you could comment on what the canonical legs on a glass of wine can tell you. When people say, like, I can see legs in my glass, what does that actually mean?
Well, I learned early on that it was an indicator of the amount of alcohol in a wine, but I don't think that's actually true. I don't know for sure the full answer, but I think that there's a lot of different things in wine that can affect its viscosity, and I think that's really what you're getting is a wine that's a little bit more viscous is going to have these kind of legs that come down, that trail down. And there's different kinds of sugars, even some non-fermentable sugars, so maybe there isn't glucose, but there's some other like oak sugars, something like that could be in there. The acidity, a lower pH versus a higher pH wine might give you different legs.
There's small amounts of glycerol in wine as well, naturally present. So alcohol, residual sugar in general of any sort, and glycerol all create viscosity, and all of those things lead to legs in wine. And so there's definitely no direct correlation between a wine being good or bad and what its like leg profile is. But it can tell you something about the viscosity of wine, and that's about it, really. So segueing, am I missing any things that we do every day? You have experience in sparkling wine enology, and I have no experience in that. I mean, is there anything different in a sparkling wine lab?
Not really. No, the base wine itself is pretty acidic. You pick that really a lot earlier because you do have that additional fermentation. I'll call it a secondary, but it's the bottle conditioning phase. So you do have more yeast, more sugar, and more alcohol being produced. So you want to be sure that you're starting with a really low alcohol product before you do that. So just the wine itself is different, but the analyses are pretty much the same.
Okay.
You know, at some point somebody might want to measure the pressure inside the bottle, but I never did that. But I know that some labs do.
How much of a bomb have you made?
Yeah,
How much of a tiny
and
little
I
bomb?
think some places do a little bit more microbiology, like checking on their cultures, because you're using cultures so much more frequently in sparkling production, because you're doing that, bottle conditioning phase, and it's important to have a healthy, happy fermentation going into that, or a culture going into that. So,
right.
I know some places tend to do a bit more microbiology in that, but I just made it according to package instructions and hope for the best, and it always worked out. So that was good.
Yeah. So then you're not like involved in checking dosage levels, which means like you're not involved in checking levels of sugar for that secondary sparkling fermentation at all. That's all winemaker stuff.
I didn't. I mean, I made the dosage syrups and we did trials, so yeah, I guess so. But we didn't really measure anything in the wine.
Okay.
It was more just sensory by trial. We'd like make the solution and do different application rates and taste and smell and decide what we wanted to use and then just apply it.
Okay. So maybe then like piggybacking off that thought, how often do you feel like if you had to break down your job in a pie chart, what would that pie chart look like?
Well, so much of my job at Bonnie Doon is things totally unrelated to production too, that I guess my pie chart is weird, but
pie chart is weird.
Let's do like the just production pie chart.
Just your enologist or production, because it's hard to even separate those two.
Yeah.
Your production pie chart.
I actually spend a lot of time doing the like safety kind of stuff for our lab and our cellar, so that takes up a good bit of time. During harvest, everything is grapes, but the rest of the year, I'd say probably spend half time doing analyses, and then a quarter time doing safety stuff, and a quarter time doing bench trials. We do a lot of bench trials, whether it's cellar trials, like winemaking kind of stuff. Do we like this product? Do we like this method of doing things better? Or benchtop trials of like clarification kind of stuff, or stabilization, or is this wine protein stable?
So you do actively do experiments to try and better the product in concert with the winemaker.
Yeah,
Okay.
definitely.
Yep. Yeah, I would say if I had to think about my little production pie chart, I probably spend 50% of my time doing analysis. Probably 25% of my time gathering samples, honestly.
Oh, yeah.
Like literally just crawling up barrels. I probably spent 10% of my time doing dishes. So now we're at about 85%. And then I would say the remaining is data entry and probably talking to the winemaker and doing blending trials as well. Because again, getting to that final thought of like, what does that Venn diagram actually look like, where you have winemaker, enologist, and then that little overlapping area?
Well, it's really different for every winery, and I've worked at a couple different wineries, and it's been really different each one. So where I work now, I mean, I'm just a lab tech, really. I'm not making decisions. There's a really experienced and knowledgeable winemaking staff, and they are having the main discussions and making the decisions, and I'm just doing what they say.
Yep.
And I do luckily get to sit in on the conversations and learn a lot, so that's really fun. But I'm not doing any like groundbreaking, decision making stuff.
No. You're giving them the tools to help make decisions.
Yeah, just giving them data so that they know what decision that they're going to make. And at other wineries that I've worked at, there is no enologist and very little wine chemistry going on at all. It's mostly just sensory analysis. And yeah, those are kind of the two extremes of where I work. I guess I worked at a harvest at Dash Cellars in Oakland, and they do a lot of analyses, but don't have an enologist on staff. The winemaker does all of that, and he is an enologist. And so that's one of those kind of places where
that's a good one.
Everybody's wrapped up together in
Actually, I'm going to read this verbatim.
Okay.
Sorry, Dan just asked a really good question, and Dan asked for both of you, as someone who has recently become interested in wine, what are good quote-unquote starter wines to try to develop a more refined palate or for recognizing wine components? You said that may be a record for saying wine as many times in a single sentence. So what's like a good... I guess what's a good starter wine? Can you even answer that question?
Well, I mean, there's some really classic grape varietals, the noble varietals that are a good place to start. Chardonnay, Pinot Noir, Cabernet Sauvignon, Merlot, tend to be French, that just have really classic characteristics, classic aromatic and sensory characteristics that allow them to be pretty easily identified when you've tasted them a bit. So familiarizing yourself with those is a good place to start. When
I like to think about getting to know wine and where you should start, I like to think about, and my girlfriend Alyssa and I talked about this because she did a video on it. I can link to it. It's actually a really good video. Alcohol, acid, tannin, and sugar. Those are 4 structural components that are going to be in wine. And if you can identify those and decide if their structure is balanced or behooving to you, you can kind of decide if you like a wine or not. So if we're making it real simple, alcohol is the difference between grape juice and wine, right? And you can feel alcohol because it will be quote-unquote hot if it's too high. So if you consume wine and you kind of blow out and there's a little bit of a burning sensation, or like you just took a shot of vodka, the alcohol level could be a little too high. Sugar. Residual sugar, as we mentioned, is a thing that a winemaker can have a decision over. Residual sugar is going to feel kind of viscous on your palate. It might also feel sweet. Most consumers can't detect sugar levels below 2 grams per liter of residual sugar, but you can feel it even if it isn't sweet. So you can decide if you like residual sugar or not, because it'll kind of coat your whole mouth with this sort of viscousy, sugary feel. There is acid. Acid is going to make the back of your mouth water. And so if you have a wine that has super high acid, super low pH, you may find your mouth watering a little bit. You can decide if you like that or not. And then tannin is going to be mostly in red wines. It gets kind of complicated. But my dog is really not happy right now, for the record. Tannin is going to give you that kind of astringent mouth drying feel, like you just went to the dentist and they shoved all that cotton in your mouth. And tannins, because tannins pull fats and proteins out of solution, including the things in your saliva. And so if we think about tannin, acid, alcohol, and residual sugar and what those things do to your palate, you can then decide if you like a wine. So I think if you're looking at the classic varietals like Abby had mentioned, like Chardonnay or Merlot, or maybe even Cabernet or a couple of others, take those wines and then ask yourself what their structure is like, and then ask yourself what kind of things you can smell. And then ask yourself if you like it, right? Because at the end of the day, wine is something that we consume because we enjoy it, because it has cultural relevance, historical relevance, and because it brings people together, right? So you want to bring something to the table that you want to enjoy with your friends. So look at those structural components, look at those aromatic components, look at those palate components for flavor, and decide, do I like it? And that's going to be different for everybody.
That's the main thing.
Yeah.
If you like it, it's good.
Yeah. Sorry. You're right. I can't actually read this, apparently.
Yeah.
Have to go now for dinner. Great. All right. Enjoy your dinner. So are there any final questions on anything regarding wine chemistry? Because I actually don't know where we're at time-wise, but I think we're approaching the end. Oh, Dan had a question. I'm sorry. I have to keep getting up. This is actually really poor planning on my part. Difference between different tannin chains. I'm definitely into red over white. Okay. So, Dan, here's an idea for you. It might be hard, but not impossible. So if you want to understand the difference in tannin chains and how they feel, if you can, go pick a Vitis vinifera or wine-growing grape off a vine and eat it very carefully. So a ripe one that's about ready to be harvested. So yeah, this gets a lot harder than it sounds pretty fast. But if you were to taste that grape off the vine and be very careful to not chew the seed first, you would feel a little bit of astringency on your palate. It would feel a little bit drying, but then it would just feel kind of sweet and acidic. The minute you bite down into that seed, it's going to get absurdly astringent. It's going to get very drying. And so those different kinds of lengths of tannins contribute different sorts of mouthfeels. So short tannins are in the seeds, long tannins are in the skins and the stems, and they contribute different profiles. And as a function of time, tannins will polymerize in wine. So you'll go from shorter chains of polyphenols or tannins to longer chains, and those longer chains are softer. So if you also have the luck of being able to try the same wine from, let's say it's a red wine, probably from multiple vintages, say 5 years apart, you can maybe start to differentiate how those tannins feel on your palate. Oh my gosh, Owen. Sorry. My dog is like, why am I still in the house and you're not? Abby, is there anything you'd like to kind of close with?
I don't know. I think it's just a good thing to remember that with the winemaking process in general, it's very cyclical and seasonal. So it's a fun job for me because I'm not doing the same exact thing every day, and I've learned through a few disastrous attempts at other careers that's not going to work for me. I can't do the same thing every day. So I like to have that variability, and there's always different questions to ask, and every lot of wine is different and interesting and unique, and it's a really fun way to combine, what I see as kind of like art and science into one career.
Yeah, totally. Yeah, I think it's probably the best part about it is that it lets your brain be creative. Like we talked about those sensory impacts. And you also obviously have to be a scientist because you have to give a winemaker data. They need those numbers, and that kind of depends on you. And I keep screwing myself over by sitting down so far away from my phone. But he said it's actually very feasible. Oh, it's a vineyard 20 minutes away. That's rad. Okay, is there any project you want to promote that you're a part of that you think is really rad?
Goodness. Well, what I'd like to...
Goodness.
I think
goodness me.
one thing I'd really like to talk about is the Santa Cruz Mountains appellation in general. I do really think that it's a really interesting and unique appellation, and in fact, it should potentially be divided into several different appellations if you're wanting to think about wine growing regions being something that produces a unique, distinctive style of wine based on the vineyard or the climate or microclimates or whatever it is. But there's some really wonderful wines coming out of Santa Cruz Mountains now, and some really interesting people that are
that's
are part of it,
understatement.
And getting involved and feeling really passionate about it. So if everybody out there, if you haven't had a wine from the Santa Cruz Mountains, I really encourage you to give it a try. And there's some really incredible wines coming from this area.
Yeah, absolutely. I think it's actually a really good spot to end on. What a lovely thought. Anyway, thank you guys for joining us. I hope you enjoyed learning about what science wine lab rats do every day. And if you have any questions, feel free to leave them in the direct messages for the SciCommunity, and I will be addressing them over the next couple days. But we have like a lot of salad and fruit and cheese and crackers and olives to eat, so we kind of gotta get cracking. So I'll see you guys next week.
Bye. Thank you.
Bye.